In this video, I'm going to be working BC Homework 10.4 and finding a bunch of areas inside polar curves. So the first one is the graphs of r equals 4 and r equals 3 plus 2 cosine theta are shown in the figure. They intersect at pi over 3 and 5 pi over 3. Okay, that makes sense. Find the area of region R. Okay, now this is going to be one of those where if we start at the origin and we go out to the far edge, we're hitting both curves, so that's where we're going to need to subtract. So we're going to be taking the outside area minus the inside area, but we can do that with a single integral. So it's going to be the 1/2 r squared d theta minus the other 1/2 r squared d theta. Looks like on the outside is the circle. That's going to be r equals 4. And on the inside was the thing with kind of the lumpiness, which is going to be the more interesting equation, 3 plus 2 cosine theta. But this is a calculator question, so... you could figure that out by just graphing one of them at a time. For instance, r equals 3 plus 2 cosine theta, and saying, okay, well, that's the one with the lumpiness to it. All right, and then we're going to be integrating that from pi over 3 to 5 pi over 3. And so I'm just calling for that integral. Okay, I need to put the 0.5 on the outside, then from pi over 3 to 5 of pi over 3, 16, well, minus 3 plus 2 cosine t squared. That's the end of the integrand dt. All right, 21.730. All right, the next one we're going to find the areas for regions R and S. And so both of these, we're going to have to use a calculator to find the areas. So we can figure out which one was which by graphing them one at a time. So R equals 1 plus sine theta cosine 2 theta. Okay, we need the parentheses. Okay, and for 0 to pi over 2. Okay, so I'm not super... 2 cosine theta is going to be the more circular one. But if you weren't sure about that, you could, 0 to pi over 2. Yeah, you can see, okay, the 2 cosine theta, g of theta is on the outside. I might actually write that. Okay, so the area of region R, I'm just going to find by integrating f. So the area formula is 1/2 of the integral of r squared. So I'm just going to say f of theta squared d theta. It says from 0 to pi over 2. Okay. Now, what I'm going to do is, instead of r, I'm going to call this f of theta, and then it is going to change the graph and not be polar anymore, but I don't really care. I can turn that off. Now I'm interested in the 1/2 of the integral from 0 to pi over 2 of f of theta squared d theta, and I can get 0.648. And then if I were to do the area of S, I'm going to have to subtract. Now you could do it as the integral of g of theta squared minus f of theta squared, 1/2 of that, from 0 to pi over 2. But since we already found the area of R and R is entirely contained in S, we can just find the integral of g and subtract the 0.648. So I'm going to say that this is 1/2 of the integral from 0 to pi over 2 of g of theta squared d theta minus the 0.648. Okay, and, call that A. then I'm going to do 1/2 of the integral from 0 to pi over 2 of g of theta. I don't think I've defined that yet, have I? Yeah, that's a quick fix. G of theta squared d theta minus a, and get 0.922. This is, okay, we're looking at the shaded region, and this is where it's going to hand off from one curve to the other. So it starts off with this curve, and then it switches over to the circle. All right, and so I'm going to just say, okay, to get the red area, it's going to be 1/2 the integral from, you can tell from the graph it's 0 to pi over 2 because it's the first quadrant, of 3 minus 2 sine of 2 theta. Square that. And that's going to get me, that amount of area right there. And then I'm going to add, you do it as an integral, but to me it's like this is a quarter circle, so I'm going to say plus 1/4 of pi, so radius squared, that's going to be 9 pi over 4. Okay, so I'm going to go to the calculator. And probably clear out a bunch of stuff. So right now I just need an integral, so 0.5 times the integral from 0 to pi over 2 of 3 minus 2 sine 2 theta squared d theta. I'm looking at those parentheses, yeah, that looks right. And then we need to add plus 9 pi over 4. I get 9.708. Got another one. Okay, this one's a little more tricky. It is very generous of them to give the intersection points. We appreciate that. Pi over 6 and 5 pi over 6. Now, I think with a little bit of strategy, you can make this one a lot easier. Yeah, so what I'm thinking I'm going to do is I'm going to start at pi over 2. Now, you could do this by just starting at 0, integrating the circle up to pi over 6, then integrating this other curve from pi over 6 to 5 pi over 6, then integrating back onto the circle the rest of the way to 2 pi. But I think that's unnecessary. So what we're going to do is we're going to start at pi over 2, and we're going to integrate on that curve up to 5 pi over 6. And then we're going to pick up integrating on the circle and integrate to 3 pi over 2. And then we're going to double the result. All right, so the plan is multiplying 2 times the integral from pi over 2. I didn't put the 1/2. Maybe I'll just start over. Pi over 2 to 5 pi over 6. On r squared, this has got to be the 4 minus 2 sine theta. One half r squared d theta. And then I'm going to add the red area. And that's going to go from 5 pi over 6 to 3 pi over 2. And that'll give me the left half of the area, and then I'm going to double it. And that's why I've got that multiplication by 2 on the outside. And so it's 1/2 r squared d theta. And if you wanted to just figure out what proportion of the circle that was, then you could totally do that. I'm also seeing a way that you could just do like that whole portion of circle that corresponds to 5 pi over 6 forward to, I guess, 13 pi over 6. You could do that and then just find the area of the lumpy region, add those together. It's going to be equivalent. I'm already this far into this one. I'm going to do it this way. Okay. So I'm going to have 2 of the integral from of half the integral of pi over 2 to 5 pi over 6. Plus 1/2 the integral all right, yeah, 24.709. Oh, is that gonna be right? 3. Okay, well, the area of the whole circle is 9 pi, which is more than 27, so yeah, I guess that's reasonable. I'm gonna find the area in the second quadrant enclosed by the coordinate axes. Okay, second quadrant, so we need to draw a diagram. The graph of 3 theta plus sine theta. Well, I think it's gonna look something like that, you know? The curvature, I have no idea. I mean, I've got a calculator here, and no shame in using it right now, it's just the homework. Okay, okay, that's my best sketch. But really what we need to know is that it's gonna go from pi over 2 to pi. We need to integrate 1/2 r squared d theta. And I wonder if with that definition of r, I actually don't know if this is going to work. 47.513. Yeah, that's what I got last time. All right, so yeah, that works. That's nice. But I'm not sure what would happen if you had more than one r defined there. So I would be careful with that strategy. Okay, now the figure below is showing the graph of r equals 1 plus 2 cosine theta for theta between 0 and pi. Find the area of region S. Okay, so what we're going to need to do, we're going to need to do a little investigation. R equals 1 minus 2 cosine theta. And there aren't too many that are like this, but yeah, if we graph this from 0 to 2 pi, we're going to see more graph. So what we need to do is obviously narrow it down to 0 to pi, but that's going to show us what we already know. Now, if I do 0 to pi over 2, and see, oh, okay, maybe see what's going on there. You could think about where it equaled 0. Okay, but this is a calculator problem, so we might as well just kind of like figure it out by messing with the bounds. It's probably going to be unit circles, so not pi over 6, maybe pi over 4, no. Pi over 3, yes, okay. And that also makes sense because cosine of pi over 3 is 1/2. All right, so I know that this region S is really running theta equals 0 up to theta equals pi over 3. And the vast majority of the problems are like the ones that we've done so far, the first 5, where you could just either tell the bounds from, the context of the question, or they were outright given to you. This one we had to do a bit of work. But if you got a calculator, you can just kind of toy around with it until you figure it out. So 0 to pi over 3, and if there's two curves and they're not trig and they're just going to intersect at some unit circle value, you do need to graph them rectangularly, but hopefully that's going to happen later on in this video. So theta equals 0, theta equals pi over 3, we've got our bounds of integration. Integrate 1/2 r squared d theta, and that's going to equal 0.21272. Alright, now we've got one that's very similar to that one we just did. Okay, it's just turned sideways. Okay. R equals 2 and R equals 3 plus 2 cosine theta are shown in the figure below. We've got the intersections, 2 pi over 3 and 4 pi over 3. Again, we're appreciative. Okay, what we're going to do is, yeah, I think what I'm going to do this time is I'm going to say, okay, what is 2 pi over 3 to 4 pi over 3 is the width of 2 pi over 3. So there's 4 pi over 3 left. So that's 2/3 of the circle. Okay, so 4/6 of the circle is what I am going to be just kind of like, coloring in blue. So that's 2/3 pi radius squared. So that's 8 pi over 3. And we're going to add that to, I'm going to integrate on this curve between 2 pi over 3 and 4 pi over 3. I'm going to use that strategy I didn't use last time. 1/2 the integral from 2 pi over 3 to 4 pi over 3. R squared is 3 plus 2 cosine theta squared d theta. And at this point, all I really need to calculate for is the integral. So 8 pi over 3 plus 0.5 times the integral of 2 pi divided by 3 up to 4 pi divided by 3. 3 plus 2 cosine theta squared d theta and get 10.370. All right, area of the region bounded by the curve in the x-axis. Okay, this is going to be 0 to pi. Okay, don't make it too hard on yourself. You can see that at theta equals 0, r is going to equal 0, and it's going to the negative x-axis. That means 0 to pi. Okay, again, there's nothing else we're doing with this curve, so I'm just going to type in the integrals, or I don't need the graph, of r was theta plus sine 2 theta, to square that, theta 4.382. All right, now this one's a little tricky just because of the way that you have to think about adding up the areas. So I'm going to zoom way in. I'm going to draw it ahead of time. All right, so I know this problem has historically been difficult for students in my class, and I think it's just because of the visualization. But I think I've got it here. We've got the two different curves, two circles with different radii. And so what's going to happen is we're going to start at theta equals 0, and we're going to be integrating on the blue circle. So, whoops. We're going to be starting right there. And then we're going to be adding up these piece of pizza areas till we get to the intersection. And the intersection is going to happen. And after that, we're going to be integrating on the red circle up to what I think is going to be pi over 2. And notice how those radial lines, those values of theta, they're getting more vertical, but they are in the first quadrant still. So it looks to me like theta is approaching pi over 2. So I'm going to be going from 0 to the intersection point on blue and the intersection point to pi over 2 on red. And you could, kind of verify this with the calculator if you liked, but I'm going to just keep going. R equals root 2 and R equals 2 cosine theta. So really our job right now is to find the intersection point. And what you could do is, this one would be pretty easy to do by hand. You could say square root of 2 equals 2 cosine theta, and that's root 2 over 2 equaling cosine theta. That's where theta is pi over 4. And it kind of looks like that from the diagram, so that's just confirming what we already know. But if it wasn't going to be a nicely solvable equation like that, what you do is you say y equals square root 2, graph it rectangularly, and y equals 2 cosine theta, and you go, okay, well, we're expecting it to be between 0 and pi over 2, so like between 0 and 1.5. There it is, pi over 4. It's even telling you the exact value on decimals. It's really nice. All right, so we've got all that. We're ready to set up our integrals. Say integral from 0 to pi over 4 of 1/2 is going to be the smaller circle. But it's the one that's not centered at the origin, so that's r equals 2 cosine theta. It's a little tricky. We're going to add area on red, so it's going to be 1/2 the integral from pi over 4 to pi over 2 of... Wait, no. Blue was the circle that was centered at the origin. Okay. That doesn't really not gonna make sense. Okay, so root 2 squared. And you could just say that that was what's going to be 1/8 of the circle, and that might have actually been wiser. Gone this far now. 2 cosine theta squared d theta. Okay, but I guess it's not too late to simplify before I plug it into the calculator. This is just 1/8 of pi times root 2 squared. Okay, yeah, it's 1/8 of the circle. 2, and then that's a quarter. Yeah. Plus, and then when I square 2 cosine theta, I'm going to get 4 cosine squared theta, but I'm going to divide by 2, so that's going to be the integral from pi over 4 to pi over 2 of 2 cosine squared theta d theta. Yeah. So pi over 4 plus the integral from pi over 4 to pi over 2 of 2 cosine squared t dt. That's 1.071. It looks like that makes sense. Okay, graph of r of theta is shown below. Find the area of the shaded region. Okay. This is gonna be not one that we can do by hand. This is a calculator one. So integral from 0 squared to pi 1/2 r squared d theta. Three square root theta sine theta squared. Okay, that was r theta. I need to square that and integrate 3.534. All right, now we got a multiple choice situation. Which of these gives the area of the region enclosed by the one loop of the graph for cosine 3 theta? All right, so what we need to do is think about where that's equaling 0. Okay, this looks like this is at theta equals 0 right here. So I probably have a positive and a negative value. Okay, cosine 3 theta equals 0. Okay, well, cosine is equal to 0 on the unit circle. I'm assuming this is no calculator. Over here at pi over 2 and negative pi over 2. And that's what 3 theta has to be, because that's like the inside of cosine. So I've got pi over 6 and negative pi over 6, which, okay, that does help me eliminate 2 of the answer choices. All right, and then it's 1/2 r squared d theta, so 1/2 of 16 is going to be 8. And we need to remember to Square the cosine. Okay, 8 gets rid of that one. We need to square. Okay, there you go. Yeah, that's, oh, whoops, you couldn't see that because the calculator should have gotten rid of that. But that's very typical for these polar multiple choice questions. You can definitely work them on the process of elimination. That 1/2 r squared d theta formula. All right, now the area of the region inside for sine theta and outside. Oh, goodness, r equals 2. All right, so this one, you can tell it's old. It's got 5 answer choices, and I can tell based on the type it's pretty aged, but it's still a good question. Let's just see where 4 sine theta equals 2. Because I think we can just solve this, yeah, as if, and just look for the 2 most obvious spots on the unit circle. Yeah, that's going to be the thing to do. Okay, so sine theta equals 1/2. I don't even really need to worry about the lower half of the unit circle. 1/2 is pretty low down. It's below, it's less than halfway, angle-wise. And so that's going to be pi over 6 and 5 pi over 6. That is definitely helping me eliminate answer choices. And then, so it's going to be inside of 4 sine theta. So if I square that, that would be 16 sine squared theta minus the inner curve that we want the area outside of, which would be 2 squared, which is here. There we go. No, it's outside squared minus inside squared, not 1 minus the other squared. Okay. It's the area of the region bounded by the graph. This is one that we can do by hand. We don't need the calculator for. So I'll just take that away. Let's see. All right. R squared d theta. What a strange function. Okay, 1/2 of theta plus, okay, theta squared. Add 1 to the power, divide by the new power. Okay, this is unusual. Must be just going to work out just right with the, so the answer choice was 1 term. 1/2, I'm going to plug in pi, plus 3 over 2 pi times pi over 1, theta squared. And that's when I plugged in theta equals pi. When I plug in 0, I'm going to get 0 plus 0. And so I must be able to simplify this. All right. That will definitely help. Pi plus 1/2 pi would be 2.5 pi. So 5 pi over 4, yep, sure enough, there it is. Okay, that was an interesting one. All right, a Wright-Riemann sum approximation for the area. Okay, remember, we're approximating the integral of 1/2 r squared d theta. Okay, so we're going to be, having our heights given by, if we're thinking of it as rectangles, which maybe you should, maybe you shouldn't. But, to make it most familiar, we're going to have 1/2 r squared as our integrand. D theta is going to be delta theta. So what I'm saying is theta equals 0, theta equals 1. This is approximated by the sum of some 1/2 r squareds multiplied by some delta thetas. Okay, so we're going to have 1/2 Wright-Riemann sum. I'll use the right edge. So 4 squared is 16. Times delta theta is 1/4. I'm going to have to write out some terms before I can see how they're factoring it. I can already see they're kind of being tricky that way. Okay, and then plus 1/2 r squared. Delta theta is 1/4 again. That's going to keep happening. So I see we can factor out that quarter, but we're probably actually going to want to factor out the eighth for the 1/2 r squared. All right, 4. Anyway, yeah, right Riemann sum. Okay. Third one's going to be 1/2 of 25. Delta theta is 1/4. Last one's going to be 1/2 of 4. Again, not the 1/4. Okay, so I'm thinking I'm going to take the 1/2 and the 1/4 out of each term in the sum. Yes, so that's going to be 1/8 of 16 plus 9 plus 25 plus 4. There it is. That's answer choice D. So that's an example of a Riemann sum. It's not exactly standard, but very doable if we keep our cool. Okay, that figure below, this is very similar to one that we did in our notes. 2 sine squared theta and 4 sine squared theta, theta going from 0 to pi. All right, so, okay, we know that the 4 sine squared's on the outside, 2 sine squared's on the inside. And when I go from the origin to the edge of the region between the two curves, I'm hitting both of them. Okay, so I'm going to need to subtract. So I'm going to have 1/2 of the integral from 0 to pi of, okay, I can square 4 sine squared theta, that'll be 16 sine 4th theta, minus 2 sine squared theta squared would be 4 sine squared theta, or sine 4th theta. Okay, so that's going to be 12 divided by 2 is 6. Right, here's another one that we can do by hand. Okay, r equals theta and theta equals k. All right, what's the area of r in terms of k? So 1/2 r equals theta squared d theta, 0 to k to pi over 2, so we're starting with 0 and we're ending with k. Yep. And because that's this ray right here is going to be theta equals k. And this is r equals theta, where the more I rotate, the farther I get from the origin. Okay, and this is something I can do by hand. I'm going to add 1 to the power, divide by the new power. That go from 0 to k. This is actually really nice. 1/6 k cubed. Oh, here you go. Alright, the graph here shows the polar curve 2 theta plus cosine theta. It's the area of the region between the curve and the x-axis. Great calculator question. You can see the decimals. 1/2 r squared d theta. And I'm going to need to bring back the calculator. Say 1/2 of the integral from 0 to pi of 2 theta plus cosine theta squared d theta, 17.456. There it is. All right, and okay, that's it. All right, so that's going to be all for this video. Thanks for watching.